Hello, sir. Good
Good
morning.
morning, sir.
Morning.
Happy Makar Sankranti.
Yes, happy Makar Sankranti to you too, sir. Are there any Makar Sankranti celebration in the school next week?
Next week, sir. Tomorrow is holiday.
Yes, correct. And then,
Generally,
okay.
generally it is on 14th January, as, as I know.
And then
But
school will begin again on Tuesday, is it? After tomorrow's holiday?
no, yes, sir. Tuesday school is open, regular, as
Okay.
usual.
Okay.
Tomorrow
Okay,
is
sir.
holiday.
Purushottam sir, that video is really good. The children playing.
Sir. But duration is very short, generally.
Yeah, yeah.
Sir.
I think it will be better. Like we just need to wait a little bit. The technology is
Uh,
advancing. Yeah.
so as the modification will be there, no, the duration will be increased.
Yeah.
Yeah.
Thank you, sir. And, in 2024, expecting many new features in AI.
Yeah. In general,
Hmm.
generative AI is getting a lot of funding. So many startups are building so many advanced features. And by that time, sir, you teach the next academic year students.
Yes.
Lot more things will be there.
Uh,
Yeah.
and sir, with ChatGPT, from the beginning only 3.5 and 4 versions are there, or in the starting only 3.5 versions was there?
Actually, they started with three, I think. There was a
3.
version three before, which was
3.
not very good.
That's,
3.5 was very good.
hope ki now in future 4 will be also free.
I'm not sure actually. Hopefully.
But we have alternative. Uh, as we can do as we do in chat gpt, so generally the image creation that can be done with
Uh, Using playground that is free.
playground and
Sir,
teachable messages.
are you teaching AI in the school currently, your school? How
uh,
many teachers? Yeah.
no sir, from the next session april we are going to start as per the syllabus, but those who are interested, some children, we are demonstrating them.
Okay.
But regular syllabus will be started from curricular will be started from April
And sir,
24.
how many students will be enrolled in that? Will you make it optional for the students or mandatory?
Compulsory, sir. It will be compulsory from 9 to 12
Yes, yes. It is very
for all
much
the
needed.
classes. Yes.
Yeah.
So almost total 250 students will be there from 9 to 12.
Okay. And teachers, sir, how many teachers are planning to?
Three teachers are there, sir.
Okay.
Three are there.
This is much.
Okay, so maybe we can get started in 2 minutes.
Yes.
Before we get started, I just wanted to share this. There was a device called Rabbit, I think, R1, which was released
Yeah.
last week. It's like
Huh.
it's a gadget which allows you to interact. So let me see if I can find a video and I can just
What's the
share
name,
it
sir?
with all of you.
What's the name, sir?
This new device is providing things at CES 20.
In the message, just to please type the name.
Sir, it's Rabbit R1. So Rabbit R1. Let me just share my screen and try to.
Rapid or
So I'll just show this for 2-3 minutes and then we'll get started with our new our lecture today.
24, and it's unlike
Are you
anything
able to
you've
hear the audio?
yes, sir. Clearly.
ever seen before. It's called the Rabbit R1, and it's a revolutionary AI agent device that can do almost anything you want it to do just by talking to it. In this video, I'm going to tell you everything you need to know about the Rabbit R1, how it works, what it can do, and why it might change the way you use technology forever. So, the Rabbit R1 is a small, unique AI device, different from smartphones or tablets. It runs on Rabbit OS and uses a technology called Large Action Model, LAM, to perform tasks without apps or APIs. Unlike typical smart assistants like Siri or Alexa, the Rabbit R1 understands complex requests in natural language and learns from your behavior. It can manage various tasks, from booking trips to controlling any app you use, adapting to your preferences. Introduced by Rabbit, an AI company in Los Angeles at CES 2024. The Rabbit R1 gained significant attention for its innovation. Priced at $199, it's set to ship around March or April. Now, this is a small, lightweight device that's easy to carry. It features a 2.88-inch touchscreen with a clear display of 640 x 480 pixels and is quite bright at 500 nits. The device includes handy features like a button for instant talking, a scroll wheel, and a USB-C port. Its standout feature is the Rabbit Eye, a unique 360-degree camera that can spin around to take pictures and videos, and it's great for advanced computer vision tasks. This camera offers an 8-megapixel resolution and covers a wide area with its 120-degree view. It even turns by itself, based on how you hold the device or where your voice comes from. The Rabbit R1 runs on a MediaTek Helio P35 processor, backed by 4 gigabytes of RAM and a generous 128 gigabytes of storage space. It's equipped with a SIM card slot for 4G LTE and also supports Wi-Fi and Bluetooth connections. The device's battery is quite lasting, with up to 10 hours of active voice commands.
What's the stock price of Coca-Cola?
The stock price of Coca-Cola, KO, is $59.76.
It watches how people use apps and services and mimics those actions. For example, instead of opening the Spotify app to play music, you just tell Rabbit R1 to play jazz and it does it.
So basically, this device was released last week, I think. And why these kind of, I think, gadgets are starting to get released is because I think the keyboard computer interface is not an optimal interface for using applications like ChatGPT. So I think these small tiny gadgets are coming up which you can take along with you anywhere. So for example, if I want to, let's say, book an Uber ride, so now I have to go to my phone, open the application, click on the destination and everything. So it's a very time consuming process. Instead of doing all that, I can simply take this device out and ask it to directly book the cab, and then the cab will be booked. So I think it can save a lot of time and make our life much simpler.
So these are the additional features besides the smartphone or this.
So actually, yeah, I think it's a device which is like an interface between you and your phone. So it lets you interact with the applications on your phone without actually opening your phone, I think. So all you need to do is just speak with the Rabbit device, and it will take the actions for you. So it's like something which is a compact device, but it is a very smart device, and it will always be with you all the time. So the reason I showed is because so many things are happening in AI every single month, and all of you, if you are up to date with respect to what new things are coming up, it will actually help you understand how the field is evolving at a very rapid pace.
Right.
So now let's get started with today's lecture. So today we'll be covering, starting or continuing with the AI model development process. In the last lecture, we looked at building building classifiers. So these could be image classifiers, voice classifiers, or hand pose classifiers. Classification is a very specific type of an AI model where you're trying to predict between a distinct number of classes, which can be either 2, 3, 4, or 5. And there are 3 main types, as we looked at: image, voice, and hand pose. And these classification algorithms find applications in a lot of different applications that we use on a day-to-day basis. Today we'll be covering at a second application, which is called as regression. So classification and regression form 2 building blocks of all the AI algorithms which you can possibly have. And today we'll be covering regression. Before we actually move into the next part, I just want to appreciate some of the teachers who shared something with us last week. So they have been using applications which we have taught them in the teacher training lectures, and this is from the DKT school. I will not be able to take names of teachers because I have not written, but I think all of the teachers have contributed who are present in the teacher training batch. So these are some of the images which were created using Playground. Very interesting images, and finally there were some set of, so this was created by Purushottam sir, people, kids playing in a playground. Then we have videos, interesting videos, but short videos, 2 to 3 seconds. I'm sure in the future more longer duration video capacity will be also coming up. This is also another fascinating video. It actually illustrates the intensity of the independence movement which was there in India in the 1900s. So you can see in the faces, the intensity is very clearly brought out. So I really like this video actually. Okay, so I just want to appreciate teachers who are trying to use these applications so that they are getting enough hands-on practice. Now let's move on to the lecture. If you remember the teachable machine model that we have explained in the last 2 lectures, there are 3 blocks. The first is where you upload the training data. Here is where you have these different classes. For example, we have cats and dogs. We have different voices. We have different hand poses. This is the training data where you upload all kinds of training data. The middle block is where we click on train model. And then the third block is where we actually test whether the model is working correctly, what is the accuracy of the model, etc. So you might have noticed that we have not focused much on this middle block. For example, what is exactly happening here? What is happening when you click on this train model part? So today we'll be diving deeper into this. We'll be taking some examples which will help you understand what does a model actually look like, and how to visualize an AI model by taking a simple example. If anyone has any doubts as we go along the way, please feel free to just stop us in between and then get it clarified. At the end of today's lecture, you will have worked on one specific example which will help you understand what is regression, what is the meaning of AI model, how to distinguish training data from the model itself, and how to visualize an AI model. Okay, so let's get into the lecture now. So first of all, let's try to understand regression. When you hear about the word regression, what comes to your mind first? Can any teacher give any answer? Regression, so what will it mean? So you can be wrong, even I was not aware of this word before until I started learning about ML. Completely fine even if the answer is wrong. So one meaning of regression is in our last batches, many teachers said that regression, does it mean retarded, or does it mean uh, that the ability to grasp things are on the lower side? So these are some definitions in the English language that we are used to. Yes, Prachi ma'am, that is correct. It is indeed a statistical technique. Now let's try to understand what regression means in the context of artificial intelligence. So we are essentially looking at whichever problem we analyze, there will be pairs of data where we'll be having an input label and we'll be having an output. So let us take an example. Try to keep these 3 things in mind: pairs of data, input label, and output prediction. So let's take the example of area of the land in square feet and the cost of the plot. Whichever area you are living in right now, there will be certain places which are costly compared to others. So let us say the pair of data is the area of land in square feet, and the output is the cost of the plot. So one thing we can understand is that the more the area of the land, the higher will be the cost of the plot. So for example, at the bottom, I have given some examples. If the area is 300 square feet, the cost is 5 lakhs. If the area is 950 square feet, the cost is 9 lakhs. So this is an example of a pair of data where you are trying to predict the cost of the plot based on the area of the land. Now, let us try to see how to visualize these pairs of data. Please ignore these red lines for now. These are from the previous batch where we have explained this graph. So what I would like to focus your attention is on this graph. So if teachers are familiar with mathematics, they will understand that any pair of data can be represented as a two-dimensional graph, where one data is on the x-axis and the second data is on the y-axis. So please let me know if you are not able to understand this graph. On the x-axis, we have the area of the land in square feet. As you can see, that we have 4 points, 300, 500, 700, and 950. On the y-axis, we have the cost of the plot in lakhs of rupees. And the green dots, these 4 green dots that I am indicating, these are the 4 data points that I have. So now there are 4 points, and I have visualized this pair of data in the format of a graph. So this is one way of visualizing data in the form of a two-dimensional graph. Now, let us try to understand this. Now, let's say if someone comes to you and asks you this question, what would be the price of the house with an area of 800 square feet? So what would your answer be? So I will pause here for some time because I really expect teachers to at least think about this question to understand what is coming next. So what would be the price of the house with an area of 800 square feet based on this graph? You can tell anything which is wrong also, that is completely fine. Just try to attempt whatever comes to your mind based on looking at this graph.
Somewhere about 8 lakhs.
Okay. So Rana sir has said somewhere around 8 lakhs. Any other prediction? Prakash sir is mentioning 8.5 lakhs. Okay. Any other guesses? Kuldeep sir is saying 9 lakhs. Supriya ma'am is saying 8 lakhs. Okay, so we can see that everyone is guessing somewhere between 8 to 9 lakhs. Prachi ma'am is guessing between 8 to 8.3. So what we are trying to do here is that in our mind, we know that it is somewhere between 7.5 to 9, but we are not able to understand exactly what is the point. Now that is what actually regression does. Regression is a statistical technique which allows you to predict from a set of data, either into the future or some information that is not available from the available data. For example, in this case, the information is not at all available to us. We do not know what is the price of a plot which has an area of 800 square feet. So we are trying to predict something which is not available in the data, which is an example of a regression. For example, let us say when COVID-19 uh, was there, and if someone had asked you the question that what would be the number of infections in the next 1 week, that is the question where no one possibly knows the answer to. But if you would have understood the problem, if you would have developed an AI model using regression, we could actually predict. The accuracy can be bad, the accuracy can be good, but it is possible to predict into the future. So that is the type of AI model which we'll be looking at in today's lecture. Whenever you think of regression, and if you are not able to recollect anything, just think of this COVID example so that you at least get an idea of what we are trying to do when someone says regression. Either we are trying to predict into the future something that is not known to us, or we are trying to predict something that is not available within the existing data.
So this here, sir, data is not consistent. Here, area is something different and price something different.
Correct.
So inconsistent data
So,
prediction for the inconsistent data, which is
yes,
not
sir.
certain,
Y-
uncertain data.
Yes, correct, sir. So in this case, this data is something which is called as a continuous data. which means that area on the x-axis can take values which are continuous. For example, 723, 724, 725. So regression is applicable to both continuous data and discrete data. Discrete data, what is the example of discrete data? Let us say we are tracking the number of hours of study which a student has done. So hours can be classified as something discrete, or number of students present in the classroom. They can either be 1, 2, 3, 4, 5, etc. They do not take continuous values. So generally there are two types of data that we see in the regression problems. Either they are discrete set of data or they are continuous set of data. Even in the example of the COVID, which I was taking, the number of infected cases. So these cases, they cannot be in decimal points. There is always an increment of 1 which goes between the different cases. Either it's 1, 2, 3, 4, 5, anywhere. It is an integer. So that is an example of a discrete data. So you can have both these types when we are considering regression problems. Okay, so now let us move on to a very practical examples which we encountered. And Dr. Raj will actually cover this example in detail.
Are you able to share screen, Raj? Okay. You're muted.
Can you see the screen?
Yes.
Okay. So, yes, so what Rajat was explaining after this regression portion is that we had partnered with a school in Palakkad, district of Kerala, actually. And our main goal initially was to train the teachers there. And the teachers were trained and they were using artificial intelligence. But then there was a very real life problem which we wanted to solve for them. And the problem was that during COVID time, of course, the motivation dropped. Students started exploring digital venues. And after COVID, the student academic performance in this school was not very good. In particular, the grades of the students were dropping and they were not performing as well as the previous batches. So then this particular school approached us that now that we have learned AI, can we actually, or can you help us use AI algorithms to somehow predict what is going wrong with the student performance, and how can we exactly improve the student performance? That was the main question. And this is a very real life and an important question. And now I'm going to demonstrate how we use the techniques of regression to solve this particular problem. So let me first actually start with a very simple toy example. This is not real data, but through this demonstration, I hope you can see the Excel sheet. So through this demonstration, what I want to illustrate is human limitations and the need for artificial intelligence in regression. So we will take a toy example of the students and the hours of study and the percentage marks, and that will motivate the story of essentially what we did for this particular school. So first, I want to show you the limitations of human intelligence, which we ourselves will recognize through this Excel sheet example. So this is a very interactive activity. So whenever I ask a prompt, please respond in the chat. So let's say that you have data of only one student, and the data says that this student has studied for 4 hours, which is also seen on the x-axis of this plot, and they have obtained 33%. Now the question which I want to ask you is that let's say there is another student who has studied for 7 hours, let's say 7 hours. Can you predict their percentage marks? So let me repeat it. You already have data only for one student who has studied for 4 hours, and she has obtained 33%. Can you predict the percentage marks for another student who has studied for 7 hours? A short poll has appeared on your screen. Please try to, all the teachers should answer on this poll. This will really help us illustrate the point if you are involved in this particular activity. So I will just wait for some time so that everyone has time to answer the poll. Okay, I hope many teachers have had the chance to answer this poll
We
question.
we have received only two answers so far. Teachers, please, any number you think makes
Yeah,
sense, you can add in the poll.
even if you're, so Purushottam sir has mentioned 55 in the chat. Even if you are not confident, just add something, because that is the whole point. We want to show something related to the confidence of the prediction. Okay, so everyone is typing in the chat 55%, 66%, 60%. So let me just write down the teacher predictions here: 55%, 60%, 60%. From the poll also, we can see that 100% have answered. Okay. So if any teacher has not yet written in the chat, please, I encourage you to write it so that we can record all the responses as we go forward. So Sridhar is just sharing the poll results. So in my side, I could just see that 100% have answered, but I could
Uh,
not see the poll results.
I just shared the poll result in the chat as a screenshot because the poll result comes in my Zoom.
Okay, could you mention what teachers have mentioned
Yeah,
so
yeah,
I
fifty-five
can write it
percentage.
in this Excel?
Yeah, 55 percentage, 90
Okay,
percentage, then 57 to 60
90.
percentage. Yeah, 55, 90, 57 to 60.
Okay, and some of the teachers have mentioned this in the chat. So let's say these are the responses which have been recorded by the teachers. Rana sir has also mentioned 54. So let's say these are the responses which are recorded by the teachers. Okay, great. As you are mentioning these predictions, or as you are thinking about the answer, also think about how confident you are in making this prediction. Now let us come to the second question. Now you have two data points. You have the data of someone who studied for 4 hours, which is 33 percentage marks, and you also have the data of someone who studied for 7 hours, which is 58 percentage. So can the teachers predict what would be the percentage marks for a student who has studied for 8 hours? So you have the data for 4 hours, which is 40%, and you have the data for 7 hours of study, which is 60, around 58%. The question is that if someone has studied for 8 hours, can you predict their percentage mark? So again, I'll be waiting for some time here. Please mention your predictions in the chat. It is totally fine if you are not confident or you are not sure what the actual answer is. But please just make your predictions in the chat and I'll copy them in this Excel sheet. So Purushottam sir has mentioned 80%. So I have just written it over here. Other teachers, please, I encourage you to write it in the chat what you think the answer to this is. I'll just be waiting for some time. So Supriya ma'am has mentioned 75. Okay. Rana sir has mentioned 60. Then Prakash sir has mentioned 80 to 90. Prachi ma'am has mentioned 66. Okay, great. So one thing which I want you to focus on is see the big difference in the range of predictions which teachers have been making. And that is totally acceptable because the data points are less. Then Kuldeep sir has mentioned 70 to 80. Okay, so these are the predictions which have been made by teachers, and already we can see that there is a huge gap, or there is a range which is from 60 to 90. Okay, now let us come to the next, which is three data points. So let's say that we had three data points. Actually, the correct answer to the previous was 67. The next question is, let's say if you have three data points, which are for 4 hours, it is 33. For 7 hours, it is 58. And for 8 hours, it is 67. So the thing to check in this particular sheet is that very close. The third student has actually obtained 67 marks. And now the final two questions. The second last question is that you now have, let's say, 5 data points, which are plotted by these on this graph. Okay, 4 hours of study is 33. Similarly, 9 hours of study is 75. Now the question which I want to ask is, let's say someone has studied for 10 hours. Can you predict their percentage marks? So you have data for 4, 7, 8, 5, and 9, which is given here. So 4, 5, 7, 8, and 9, and you have this data. The question is, what if someone has studied for 10 hours? What do you think their percentage mark would be? So again, I'm going to wait for some time so that we can collect the teacher responses in the chat. Okay, so Prachi ma'am has mentioned 82, Rana sir has mentioned 82. Supriya ma'am has mentioned 85. Prakash sir has mentioned 90 to 95. Purushottam sir has mentioned 82. Kuldeep sir has mentioned 85. Okay, great. First of all, the first thing which you should start seeing is how close the teacher predictions have started to get. Here you see there were if we had two data points, there was a big range of the predictions. But as the number of data points increase to humans, we can see that teacher predictions have started to get very, very close. And then the last question which I'm going to ask is, now imagine you have 6 data points. So you have the percentage marks of people who have studied for 4 hours, 5 hours, 7, 8, 9, and 10. The last answer was actually 83. So many teachers were extremely close. So can you predict for the 7th student who had 12 who studied for 12 hours, what their percentage marks would be? This is the final question. So please everyone put their answers in the chat. You have these many data points, and the question is that now if someone has studied for 12 hours, what would their percentage marks be? So Purushottam sir has mentioned 90, Supriya ma'am has mentioned 95, Prachi ma'am has mentioned 99, Kuldeep sir has mentioned 96, Prakash sir has mentioned 96, and then Rana sir has mentioned 99.9. So now compare these predictions with this. All of these predictions are extremely close to each other. And in fact, the correct answer was 100 marks. So the final student had got close to 100 marks. So the point which I want to illustrate here is that as the number of data points increase, can you think of what happened to the accuracy of your prediction? Can you think of whether your confidence of making the prediction, did it increase or did it decrease? Just think for yourself as a human. Could you please type it in the chat as the number of data points increase? Whether your confidence of prediction increased, decreased, or stayed the same. So almost everyone is saying that their confidence of prediction increased as the number of data points increases. And this is exactly the importance of training data. So Prakash sir, Prachi ma'am, Kuldeep sir, Rana sir, Purushottam sir, Supriya ma'am, everyone said that the confidence of the prediction actually increased with the number of data points. And not just the confidence, even the accuracy of your predictions increased as the number of data points increased. So first thing what this does is that this explains the importance of training data for not just AI systems but for humans. This is the perfect illustration of why training data is important. The second reason why you were able to predict as the data points increased is that in our minds, as let's say we had 6 data points, our minds could see that there is a straight line which is fitting through this. Our minds could intuitively make that pattern that there is a straight line which goes through all of these points. And due to the pattern which was forming in our mind, our prediction increased. So our mental model fits a line for this prediction. And that is exactly what is called as linear regression. So the example which Rajat showed over here, this line, this straight line, is what humans can also intuitively predict if they are given a bunch of points. So why is linear regression important and why is it called as an AI model? The reason linear regression is important is because now that you have a straight line as the model between hours of study and percentage marks, you can predict the percentage marks for any given hours of study. Even if the hours of study are 1, 1.5, 2, 2.5, which are not in the training data, since you have this model, you can perfectly predict the percentage marks. And that is why linear regressions are called as an AI model. It is called as a regression model because it's a smart model. We predict for the data points which we do not have. So one question which I would like to ask teachers here is that what is the model over here? Is it the straight line or is it these points? Is it these data points which are circles? So the question is that what is the regression model? Is it the line or is it these circles? Please write your answer in the chat whether you think the model is the line or the model is these circles. So Purushottam sir has mentioned circle. Anyone else, please type it in the chat. So Rana sir has mentioned line. Supriya ma'am has mentioned circle. We can see that almost 50% of the people are thinking it's the line and 50% are thinking it's a circle. So the correct answer is that the model is actually the line. These circles are just the data points which we had. They are not the model. The model is the line because if we are given any hours of study, this straight line is going to help us answer what is the percentage marks. Let's say if the principal asks you if someone studies for 3 hours, what are the marks? You cannot get that answer just from these circles. You will get it from the straight line. So these circles are the training data points and the line
But sir,
is the model.
it is not actually the straight line because the data is not consistent. Here we see the variation from 80 to 80, 83 or somewhere it is 58, 57.
Yes,
So consistency is not there. Little variation is there. If you will
correct.
match the data, actually the straight line will not come. Actually,
So, sir,
it
in
seems
real
as a
life,
straight line.
yes. In real data which we have
Because
will never be
in
perfect.
case of consistency, or if it is
Yes.
83, hmm,
Sir, could you repeat that, please? Hello. Can you hear what Purushottam sir is saying?
Purushottam sir is muted actually, sir.
yes, sir.
Sir, what were you saying? Could you please repeat that?
I was telling sir, actually it is not a straight line because consistent data is not there. There is a variation, even 1%, 2%, 3%. Straight line means the consistent data. If it is starting to end, if it is continuous, then straight line will be there. If it is varies even 2%, 1%, so straight line will not come.
Correct.
It will be little difference will be there. It seems as a straight line.
Sir, the main point of a model is that we try to approximate the underlying data as best as
Yes.
we can.
Huh.
So if you look at the real life data, it will never be a perfect straight line.
Yes.
So the reason we want a model is that we are trying to do our best approximation which we can, so that if you are given any random data, you are able to predict what the answer is.
Predicted is always approximate, not accurate.
Yes, always, all the time. So one of my professors used to say that all models are wrong, some are useful. So that actually means that all of the models which are existing, which we make, there is some or the other error because the real life data is always messy.
Right.
But we try our best so that we can, let's say, model a straight line. And that is the main point of linear regression. Regression means that you try to fit a straight line through the data which you have.
Sir, basically it means that we are using this mean median mode, same as it works on the same principle, right?
Yes, exactly. So actually, the straight line equation, if you look at the line equation itself, the offset of the line is, I think, given by the variation, and one of the slopes is given by the mean. So if you want to get into the mathematical details, then there is another theory for how the equation of the line itself is obtained. Now, Sridatta had put this poll about why is the line called as the model, and the first option was because it passes through the data points, and the second option was because it can predict the output for any input. And I can see that 100% of the people who have answered have got it correct. That's great, which means that hopefully teachers in this call have understood the difference between a model and training data points. But now let us get to real life situation. Let us get to a real world data. Here we only had one variable, two variables, right? Hours of study was on the x-axis and percentage marks was on the y-axis. That's it. But when we actually visited this particular school, they had so many other factors. It was not just hours of study, it was sleep duration, number of practice tests which the students had solved, the class position, whether someone was sitting in the first bench, whether someone was sitting in the last bench, the attendance, whether the attendance of the student was good, whether it's not good. So let's say in a real life data, you have these other variables which affect the marks of the student. So not just hours of study, sleep hours, practice exams also affect the marks of the student. And now I want to ask you, as humans, try to guess the answer. If you have this underlying data, let's say if you have this data given by these circles, and if I ask you that if someone has studied for 12 hours a day, what would their percentage marks be? Can you please try to answer? If you have this data, okay, imagine this is your training data as a human intelligent system, and if I ask you this question that if someone has studied for 12 hours, what would their percentage marks be? Can you please try to answer it in the chat? So Purushottam sir is saying 100%, Rana sir is saying 100%, Supriya ma'am is saying 100%. Okay, almost everyone is thinking that the answer is going to be close to 98 or 100%. And the reason is because as humans, we look at this graph and we see that it's going up, up, up. So at 12, maybe it's 100. But do you know what the real answer for this is? The real answer is that the actual percentage marks decrease if someone has studied for 12 hours. And this is because there are other variables. It turns out that if someone has studied for 12 hours, we cannot just look at this one variable. It turns out that this particular person, what if they have slept very less? What if they have slept only for 2 hours? So then the marks would actually decrease. So it turns out that the marks decrease. And this is the first limitation of if we as humans are given patterns, we try to extrapolate from the given patterns. but we are only good if there is a single variable. We are only good if there is only one variable, like hours of study. But if there are two variables, if even there are two or three variables, it becomes very, very hard for humans to predict what the answer would be at a future time point. And it's even more harder for humans to come up with a model which takes into account all of these three variables and then produces the final answer. So again, Shridath has asked the question that what is the model here? Is it the data points? Is it this curved line? Or the third option is that the first two options are not correct. It should be a straight line. So please feel free to answer this poll question. We have specifically designed these questions to test the understanding of the teachers. Okay, so we can see that there is a big spectrum of answers. About 50% have answered it's a curved line, and the rest have answered that it should be a straight line or the data points. So again, the correct answer is that the curved line is the model here, because this line is going to help you estimate if some other input is given, what is the output. These dots, they are just training data points. So they are not the model itself. And 33% of the participants have answered that it should be a straight line. So a straight line was good in the previous example because we saw that the models were following this straight line pattern. But in the case of complex examples like these where there are multiple variables, actually it is better to not have the straight line in this case, because this curved line can approximate it much better. If we have a straight line, it would have predicted that at 12 hours the marks would have increased to maybe 100% as everyone had predicted, and that would have been wrong. That's why we have this curved line, which is the model. So there are two concepts here. When there is only one variable used to make the regression model, such as in the example which Rajat showed, the only variable was the area of the house. In the first example which we took, the only variable was hours of study. That is called a single variable regression. In examples like these, where there are multiple variables which affect the final outcome, it is called as multivariable regression. And in multivariable regression, there are many other factors this matter. For example, everyone in this call thought that for 12 hours the mark should increase, but students who studied for 12 hours slept very less, and hence their marks decreased. They were not attentive in the exams. And all this is very difficult to fit in human understanding and intuition. The moment we get to multivariable calculus, human intelligence starts failing us. And that's why we have to turn to artificial intelligence. What artificial intelligence systems can do is that humans can guess patterns when we see straight lines. AI systems can guess patterns for as many variables as possible. Imagine that we are making mistakes only when three variables are there. Imagine when there are more variables, like in our case, we had at least 6 variables in the school which we partnered with. If humans make mistakes in 2, we will definitely make mistakes in 3, and we'll definitely make mistakes in 6. And that's why we developed an AI model for this school. We developed an AI model which can take into account these multiple variables and which can actually predict for whatever hours of study or for whatever sleep hours, it can predict what the actual answer is. So a poll question has come up that is this curve a regression? This curve which is shown here. And there are two options. Yes, it is a multivariable regression, and no, because regression should be linear. So I'll again wait for some time for teachers to answer this. So 100% of the teachers have answered correctly that it is an example of multivariable regression. Great, which means that teachers have understood the difference between single variable regression and multivariable regression. Hopefully, through these set of Excel sheets, we have demonstrated two things. First is definitely the importance of training data. As the number of data points increased, our belief in our prediction and the accuracy increased. And secondly, we understood the importance of why AI models are needed as the number of variables increased. And thirdly, we looked at two types of regression. We looked at linear regression and we looked at multivariable. We looked at single variable regression and we looked at multivariable regression. Many of you might be thinking that, what is this AI model? And can we learn about this AI model? Yes, definitely. So the next lecture will be specifically geared towards understanding what these AI models are, which can, let's say, take into account these multiple variables and predict the final answer. So what we did for this particular school, just in conclusion, is that we developed an AI model considering all these aspects, and we gave them that model, which means that if some student had, if a student's sleep duration was decreasing, or if a student was consistently sitting at the back of the class, they could see that this is impacting the student performance, and they could take remedial measures such as asking some students to sit in the front to pay more attention, or asking some students to really improve their attendance. What we noticed was lower attendance was one of the most leading indicators of low performance. So this is a hands-on introduction where you made your first AI model, which was linear, and we were quite good at it. Almost everyone got this final answer correctly. In the subsequent lectures, we will actually be looking at real-world examples, and we'll be looking at how AI models are made and what can AI models do which humans can't, especially for such multiple variable issues. Okay, so we looked at this, and then just one last thing which I want to say in my part is that when I was doing my PhD, my problem was actually analyzing the number of COVID infections as a function of time. And I used a regression model for this. It was an AI model and it was a multivariable regression model. So, of course, as with all models, this does not fit the data pretty well, but it's a great approximation because it really helps us identify the trend of when the infections are increasing. So here you see it's an upward trend. So it's a sad sign that after even this time point, the infections are going to increase. So this was the model which I had developed during my PhD, and it was based on, it was a bit more complex than these examples which we took, but the basics were very similar. The basic was, it was an AI based regression model. And even we can do predictions with regression models. So if these are the blue line is the confirmed COVID cases, and the green line is our prediction model. And that's why models are used, because policymakers want to know whether infections are going to increase or not, because they want to take decisions such as whether they want to impose a strict quarantine or whether they want to impose a stricter lockdown policy, etc. So yeah, so this was the end of my section where I tried to explain single variable regression, multivariable regression, and AI models in practice. So now I'll just stop sharing. So I just wanted to give one practical example of how we can use these concepts of classification models and regression models to help understand some practical problems. So I'll just share my screen and I'll ask a particular question to everyone. So this was a news which was recently released in the area of Baramati. There was an initiative announced where the idea was to start an artificial intelligence for agricultural technology and climate change. So why was this launched? This was to help farmers, and it was basically aimed at harnessing the power of AI to support farmers and address climate change challenges. So now there are several things that are mentioned in this article. The question that I want to ask is, so let's say now, if you look at this paragraph, which my mouse cursor is there, so it's written that the AI will help the farmers for better management and yield prediction, water resource management, drought forecasting, efficient farm resource allocation, soil management, crop rotation strategies, pest and disease control, etc. So, can anyone tell me which of these are examples of regression? Which of these are examples of classification? This is a very specific application related to farming, which is extremely relevant to real life applications.
Drought forecasting,
Yes, that is an example of.
regression.
Yes, sir. That is very much correct. Drought forecasting is definitely an example of regression, and I hope how now you can understand how this works. This is definitely something approximate. It is not an exact science, but the same thing that we saw in the line model. This is also something similar. Based on what the weather conditions have been in the past, the AI model is used to predict if in the future when will the drought be there, and then the farmers can plan accordingly. Any other example from this?
Pest control, pest and disease control.
Okay, and that is an example of.
Even that is also an example of a regression.
Okay, sir, can you please explain how it is an example of regression, pest and disease control?
By the last year's, the previous year's data, or the, like what you have used for COVID control, same way we can use that.
Okay, okay. Okay, so pest and disease control is something which is a bit more complicated problem, I think. I think how this works is that using, okay, so let's say there is a crop. By taking an image of the crop, I think you can understand if the crop is in a healthy state or it is infected by some insects. So I would actually consider this as a type of a classification problem, because the farmers would use the classification problem to identify which crops have been infected by insects and which have not. So whichever crops are not, and they are yet to be infected, they can use the pesticides and they can use the pesticides and insecticides more on those crops.
Mhm. Yes. Okay.
Yes, sir. So throughout these paragraph, we can see a combination of classification and regression being used. I think Prachi ma'am has also mentioned in the chat about yield prediction. So yes, 100% yield prediction is also an example of regression, because it is very helpful for farmers to be able to predict what the yield will be in the future. Any other examples anyone wants to give? Thank you, Rana sir, for giving the answers. Okay, so you can see that uh, whichever problems which involve prediction or forecasting or allocation, these are actually, they can be classified as a regression type of problems. Then whichever problems use the word classification, or you're using some kind of a classification algorithm, and there are different classes involved where you're dividing into good versus bad, etc. For example, if you consider the medical field, then there are a lot of classification algorithms, because the doctors have to classify whether, let's say, you are analyzing a tumor, it can be a benign tumor or a malignant tumor. So there are two classes involved here. That is an example of a classification problem. So wherever you encounter such articles in the paper, instead of just reading them, try to go into a bit more detail. Try to think about which problems of these can be classified into regression, which can be classified into classification. What is the training data? If we are using regression, what is the training data that we are using? For example, in the yield prediction, that is definitely a regression type of a problem. But what is the training data which is used here? It is definitely the yield which the farmer has had in the past years, which can be used as the training data. So try to think of these aspects also, the training data, then the type of the problem which it can be classified into. So Raj is also saying that farm resource allocation can be considered as a classification because we can consider different categories like wheat crops, rice crops, etc. So if the farmer wants to decide which crop should I grow in this area, then there are multiple classes which the problem can be divided into, and then he can make a decision based on any particular class where the yield will be maximum in that area. So that can also be considered as a classification type of a problem. So you will be reading such articles very frequently now. But having gone through this course, we really expect everyone to have a much deeper understanding of what these AI models actually mean. Most of the people, they simply glance through these articles, but they don't really understand what is happening. But through these examples, we hope that everyone understands what is the meaning of classification, regression, and how these are applied in practice. We will also be looking at some very practical examples in the next week on how the AI models actually look like in some very real life scenarios. So there are some excellent examples which we have planned so that you can get an understanding of how these models actually work in real life and how they can be very useful for predictions or classification type of problems. Are there any doubts or any questions with respect to today's content? It was a bit theoretical, but it was very important to teach
Sir,
you.
in classification model, do we have the accurate data? Almost the consistency is there. Whereas the in regression, we have some
Yes, correct.
variable data
So in
where we
regression
cannot
model,
predict anything
yes, sir. So
clear.
how do you judge whether the regression model is good or not? There is a metric called as accuracy of the model. So if the accuracy of the model is more than 90 to 95%, it is generally considered to be a good.
Hmm.
So it is not an approximate science because you're trying to predict into the future. Even the yield, when we talk about yield prediction, we are giving the farmers a rough estimate of this is what the yield will be next year. And it can be completely wrong also. But if the accuracy of our model is good, then we expect our predictions to be generally correct or correct in the ballpark range. It can go up or down, but it can be generally considered to be the correct range of data.
Based on the previous data.
Yes, yes.
Hello,
Yes, sir.
sir. From the curiosity, I'm asking, can we use this regression data for stock market making money?
Yes, sir. Actually, that is a great question. I think stock market AI has been trying to be useful, but I think it has failed, right? It has failed at, yeah. It's not very so stock market. So there are these competitive trading firms which regularly employ PhD students from MIT, Stanford, all the best places in the world, and all their job is to come up with models, to come up with models for whether a stock is going to go up and stock is going to go down. But sir, like whether stocks is also chaotic system. The reason is because it depends on human decisions. So it's very difficult to predict regression models for chaotic systems like a weather prediction. So there are non-chaotic systems also, like COVID infection is a non-chaotic system. It has an underlying mechanism, and that mechanism is spreading, and hence we get the infections recovered and those quantities. But a stock market depends on some things like what a human is thinking on the given moment, whether someone randomly decides to sell. It's very hard to incorporate all of those effects. So regression models, there are some models, but I would not say rely on anyone for making actual financial decisions.
Okay.
Yeah. There have been companies who have been trying to, I think, sell these type of models to people, but I would be very hesitant to apply to any of these.
Yeah, one of my friends works in a company called Quantitative Brokers. It's a US based company. So they do trading in nanoseconds. Nanoseconds meaning they have to take decisions in nanoseconds. And the way it works is in a such short duration of time, there will be a certain kind of fluctuation in the. So basically, the price of a stock is determined by the demand and supply. So if I am I'm trying to sell the stock at 100 rupees, and people are trying to buy. If there are requests from people who are trying to buy the stock at 100 rupees, then that order will be placed directly. But if I am trying to sell at 100 rupee, and but in that exact same moment somebody is only willing to buy for 99 rupees, then in that moment someone else who is trying to sell the stock for 99 rupees will be successful in selling. Now if there are large number of people who are trying to sell at the same time, if there are large number of people who are trying to buy, your success of a large quantity of trade depends on how you very very quickly try to price your bid. Like if you're trying to buy, how well can you quickly price it, and how well can you quickly price it if you're trying to sell. So they're trying to build this machine AI algorithms which can like create a pricing in a such short duration of time, so that the trade can be executed really really fast, and then it can maximize their profit. So they say they are trying to kind of leverage something called as arbitrage. Arbitrage is something like there is a free opportunity, like a free lunch. Free lunch meaning the opportunity is just there for you to grab. Like if you do it, you will 100% make money, kind of. But it exists only in such a short duration of time, in nanoseconds. So their model is around grabbing that arbitrage in nanoseconds of time using sophisticated AI algorithms.
And sir, in Binance, I think the AI bot was working completely this trading in Binance, not manually. It was completely based on the AI, artificial intelligence bot. The people are not controlling. Those were trading. It was completely based on the uh, artificial intelligence, most so, robotics.
Yes, actually, finance, I think,
Binance.
yes, yes. Uh,
Recently, last from during the pandemic time only, I think it was introduced Binance, when the many people started trading, they earning the on the basis of some investment.
Hello, sir. Hello.
yes,
Yes, sir.
Rana sir, yes.
Sir, when we at the background, when AI works, it is using all this regression data most of the time. Or,
Yes, actually. So it depends on the application. So let's say now, uh, you just take the example of the finance, let's say the stock prediction. So I think what it is doing is that it is taking the training data and trying to fit a model uh, along the training data, and then using that same model to predict in the future. So let's say if the model is a straight line, the straight line can be extended even beyond the training data, and then you can use that same line to predict in the future. So in the background, there is always an AI model which is working based on the training data. So if the training data is vast and diverse and accurate, then most likely your model will also be accurate.
for it is using the graphs or the data what we are giving.
So
That graphs is for us or it is for AI.
so based on the data that we are giving, it is actually fitting some graphs within that data. And then that graph is used for forecasting. So that graph is actually the model.
Okay, if there are two graphs, yeah, every time there is a one new graph coming in or a situation coming in. So what it does actually?
Yes, yes. So every time a new data is added, the graph keeps on changing a little bit. So every time, so let's say you fix on a training data, then the graph is also fixed. But if you keep on adding or deleting more data, then the graph keeps on changing. And once your training is fixed, then you don't change the graph anymore. Then you use it only for forecasting or predicting into the future.
So if we are using Chat GPT, even that time also, if we it is continuously changing its data for
So
some purpose.
yeah, I think in Chat GPT it is completely adapting based on more and more users and their interaction. So as we are interacting with Chat GPT and we are asking Chat GPT a lot of questions, it is getting better and better.
Okay.
So I think it's an adaptive model. Many of the models are not adaptive; they are static models. But ChatGPT, I think, is an example of an adaptive model, which is adapting based on how the users all across the world are interacting with it. Yes.
So if we are giving this, sometimes it asks our own. I mean, if we have liked its suggestion or
Yes, yes,
any reason,
yeah, yeah.
taking
Uh, it,
considering.
yes, yes, yes. It will actually take that into consideration. That is done by YouTube also. It will ask whether you like this video or not. And if you say that you are not interested, then you will never be recommended the videos which are similar to that. So there also it is using that information to adapt and change what should be shown to you.
So if sir, I'm giving, if I get a proper result, so it's better to like the result, so that it will give the same kind of whatever I'm liking. Is it so?
Yes, yes, correct. So if you give more feedback, if you let's say that I have liked the answer, uh, then it will suggest more such videos. So the same thing happens on Facebook actually. The If you like such content, like if you like some content, then you will be keep on uh, showed the same kind of content always. So it's like the rest of the content will not be shown to you, but the content that you like, you will keep on getting showed the same type of content.
Okay. Okay, sir. Thank you, sir.
Okay, thank you, Rana sir. Yes. Okay. Does anyone has any questions or any doubts? Okay, then we will meet again next weekend. In the next weekend, we'll actually cover some practical projects. So we'll be taking one specific problem and we'll be using the tools that we have learned to solve that problem. And this will be a very real life project and it will be very interesting also. Uh, I also wanted to show an AI kit which we had developed. Actually, last week I had visited the DKT school, and there I did not get a chance to show the kit. So basically, I have it in front of me right now. This is the kit that we have designed. It is basically an AI exclusive kit. So, which means that you can conduct all sort of projects on this kit itself, and we have actually customized it based on the requirements. So whatever things we are doing on teachable machine can be actually taken on this kit. Let's say we are using a face detection algorithm where we are trying to. There are two classes. Let's say there are two names, number X, name X and name Y. So whichever face is detected on the screen, it will appear that this is X, this is Y, etc. And there are a number of ports also all along the border of this kit. So you can attach a sound device. You can attach LEDs. So there are LEDs at the top which are integrated into the kit. So there are a number of practical activities that you can do by using this single kit. So this is actually an AI exclusive kit that we have prepared so that students can actually have some hands-on feel based on the applications that they are developing.
So if so, you are going to show how it works after any time.
Yes, actually, I would have liked to show it, but the screen should be shared. So it is better to show in person. The process is
Okay.
actually very simple. What you usually do is that let's say you open, so we have our own platform and you connect it via Bluetooth to this kit.
Hmm.
And then everything will be displayed on this kit itself. So there are multiple videos on our website also. So actually visit our website as well and see how the videos work, where we have actually demonstrated the usage of the kit.
So if you want to buy, sir, where we have to?
So actually, I am in talks with the principal of the school also, and we'll probably be installing these kits in your lab for the next academic year.
Okay, sir. So that time we can get the demonstration.
Yes, yes, that time you'll get the demo and everything. Yes.
Yeah, thank you,
Okay,
sir.
everyone. Thank you so much for attending the lecture, and we'll meet again next week.
Thank you, everyone.
See you,
Everyone, bye bye.
teachers. Glad to see that the WhatsApp group has become active. Please continue to do so. Maybe for this week's assignment, you can try your own linear regression using any kind of data in Excel, and you can try to fit your own least square linear line fit to the data. This was done by some of the teachers in the last batch.
Yes.
Okay, teachers. Then,
Sir, is there any application or website from where we can just use this regression graph chart
This sheet maybe we can share on the group, this Excel
based on
sheet.
the data?
Yes, we will share this sheet.
Excel sheet.
we will share an Excel sheet of data along with maybe a YouTube video explaining how to fit a regression model in an Excel data.
Yes, yes.
Yeah.
Okay, so okay.
In the WhatsApp group, please share, sir.
Yeah.
Thank you, sir.
Okay, teachers. Yeah.
Everyone, thank you so much. Bye bye. Bye.
Bye
Have
bye.
a nice day. Bye.